Hello everyone, I welcome you to the video lecture on transformers and generators. Today's video lecture, let us discuss the second module. Again, second module, it consists of two sections, that is tests and parallel operation of transformer, auto transformer and tap changing transformer. Let us see the contents which involved in first section of the second module, that is test and parallel operation of transformer. So in this syllabus, so there are two tests are mentioned, that is polarity test on transformer and Sumner's test on transformer. The Sumner test on transformer is also called as back-to-back test on transformer. Next point we are going to study, that is separation of hysteresis and eddy current losses. I think you might have studied the hysteresis losses and eddy current losses in your previous semesters. What do you mean by the hysteresis losses and eddy current losses? How these losses can be calculated? So that we are going to study in this particular bit. So next, parallel operation of transformer. What is the necessity of parallel operation? That we are going to study. Then conditions for parallel operation, both single phase transformers and three phase transformers. Load sharing in case of similar and dissimilar transformers we are going to study. Let us study testing of transformer. First consider the polarity test on transformer. So what do you mean by the polarity test? Polarity means the direction of the induced voltage in the primary and the secondary winding of the transformer. Obviously, you might have studied the induced EMF in case of primary as well as secondary of a transformer. Obviously, there will be a direction of an induced EMF both primary as well as secondary winding of a transformer. So what would be the direction of that induced EMF? So that is either it may be what lower polarity to the higher polarity, or lower potential to the higher potential, or higher potential to the lower potential. So that it is nothing but the what polarity of a transformer. If the two transformers are connected in parallel, then the polarity should be known for the proper connection of a transformer. Obviously, if we used to connect two transformers parallelly, in that case, polarity plays a very important role in order to connect two transformers parallelly. So since we must know the both the transformers polarity, so then we can connect both transformers in a proper way. There are two types of polarity. One is additive and another one is subtractive. In additive polarity, the same terminals of the primary and the secondary windings of a transformers are connected. In subtractive polarity, the different terminals of a primary and secondary side of a transformer is connected. That means if you consider a transformer primary winding, so obviously primary winding it consists of two terminals. So one terminal it has a some kind of potential, or you can say that that potential or that terminal is what it consists of a positive potential, and another terminal it consists of a what negative potential. So if the same thing in case of what secondary side of a transformer, so one terminal it consists of the positive potential, another terminal it consists of the negative potential. So in case of additive polarity, the same terminals of a primary and secondary windings of a transformers are connected. Same terminals means what? The same potential is to be connected. The primary winding of the uh, the primary the terminal of a primary winding it is connected to the what? The terminal of a secondary winding with the same potential. So that is nothing but what? Additive polarity. So subtractive polarity means what? Different terminals of a primary and secondary side of a transformer is connected. If one terminal that is of a primary side, that is a positive potential, it is connected to the what? Negative potential of the secondary side of a transformer. So such type of polarity it is called as what? Subtractive polarity. So let us discuss how these polarity tests can be conducted in next slide. Let us discuss both type of polarities, that is additive polarity and subtractive polarity. So this is a circuit representation of additive polarity. See, this is a primary winding of a transformer, secondary winding of a transformer. The primary winding of a transformer, the one terminal it has a positive potential, another terminal it has a negative potential. So similarly, secondary winding of a transformer, so one side it has a what? Negative potential, another side it has a what? Positive potential. In additive polarity, the voltage VC between the primary side and the secondary side will be the sum of both high voltage and the low voltage. Here I just supposed to consider one side it consists of what? The HV side, another side it consists of a LV side. Suppose if I consider the primary side it consists of a HV side, secondary side it consists of a LV side. So both side the voltmeter is connected. So in order to measure the terminal voltage, so the P suffix A, the voltmeter, it measures the terminal voltage at a primary side. V suffix P, the voltmeter, it measures the terminal voltage at a secondary side. And the sum of both these voltages which can be measured by the voltmeter VC, which is connected between primary and secondary terminal of a transformer. If these two terminal voltages are added together, if these two terminal voltages are added together, so then we can say that what? This is a additive polarity. In subtractive polarity, so let us consider this is a subtractive polarity. So here, so this terminal, this is a primary winding, this is a secondary winding. So here I just considered there is a one voltmeter VA which measures the primary side voltage, and another voltmeter VB which measures the secondary side voltage. So another voltmeter which is connected between primary and secondary side of a transformer, so it measures the potential difference. So in this case, if this measures the voltage difference between VA and VB, so such type of polarity is called as what? Subtractive polarity. In subtractive polarity, if VC is equals to VA minus VB, it is a step down transformer. So such type of transformer it is called as what? Step down transformer. If VC is equals to VB minus VA, then such type of transformer it is called as what? The step up transformer. Now let us discuss procedure for polarity test of transformer. So let us consider the transformer which is connected to a auto transformer. So through auto transformer supply is fed to the considered transformer. So obviously this is a step down transformers. How you can say that this is a step down transformer? See, the primary winding it consists of the more number of turns as comparatively what? The secondary winding of a transformer. Since this is a what? Step down transformer. Now here it consists of uh, both the winding, primary winding as well as secondary winding. The primary winding which is connected to the uh, voltmeter, which measures the terminal voltage of a primary winding. Similarly, there is one more voltmeter, that is V2, which is connected between secondary winding which measures the terminal voltage of what the secondary winding. Now here the terminals are marked. So this terminal it is named as A1, capital A1, and this terminal it is named as capital A2. So these two terminals are the primary winding terminals. Similarly, there is a two terminals are marked at secondary winding. Small A1 and small A2 are the terminals of the secondary winding. So then there is an voltmeter which is connected between the primary winding terminal and secondary winding terminal. So that voltmeter is V3. Now here, if A1 is connected to, that is capital A1 which is connected to small A1, and capital A2 which is connected to the small A2, that means the similar terminals of a transformers are connected. See, these two terminals are similar, these two terminals are similar. How you can say that these two terminals? Here I can assume that so A1 and A2, so both has the positive and negative terminals respectively. So this is a positive terminal, this is a negative terminal. Similarly, if you go for the secondary winding of a transformer, small A1 and A2 are having the positive and negative terminals respectively. If here in this case A1 is connected to small a1 and a2 is connected to small a2, that means similar terminals of a transformers are connected, then the polarity is said to be what? Additive. If a1 which is connected to the small a2 and capital A2 which is connected to the what? Small a1, so thus the voltmeter will read the what? Subtractive polarity. Here the opposite terminals are connected. So this A2, small a1, capital A1, small a2, that is the opposite terminals are connected. So in this case, so this voltmeter it reads the what? The subtractive polarity. Now the terminal capital A1 is connected to one end of the secondary winding and the voltmeter is connected between A2 and the other end of the secondary winding. Here, see, this is A2 which is connected through the voltmeter to what? The another end of a secondary winding of a transformer, that is small A2. So when the voltmeter, if this voltmeter reads the difference in that voltage, that is V1 and V2, then the transformer is said to be what? The subtractive polarity. In that case, the opposite polarities are connected, that is opposite terminals are connected. When the voltmeter, this voltmeter it reads that summation of these two voltages, that is V1 plus V2, then the transformer is to have the additive polarity. So like this. So this is how the polarity test is to be performed on the transformer. How you can perform? So let us consider a transformer. So transformer, it consists of the two windings, primary winding and secondary winding. So both the windings are named with two terminals, that is capital A1 and capital A2 is the two terminals of the primary winding. Small a1 and small a2 are the two terminals of the secondary winding. So primary winding which is connected to the auto transformer in order to feed the single phase supply, and a voltmeter which is connected across the primary winding, that is V1. The voltmeter which is connected across the secondary winding, which that is the V2. So let us assume the A1 and A2 P are having the positive and negative terminals respectively. Similarly, small a1, small a2 are having positive and negative terminals respectively. Here, if capital A1, small a1 is connected, capital A2, small a2 is connected, then we can say that So the similar terminals of a transformers are connected, then the polarity is said to be additive. If capital A1 is connected to small a2 and capital A2 is connected to small a1, that means the opposite terminals are connected to each other, and thus such type of polarity is said to be subtractive polarity. So in this connection, if the supply is given, so obviously V1 reads and V2 reads as well as V3 reads. So in this case, when the voltmeter V3, it reads the difference in that V1 and V2 voltage, then the transformer is said to be connected with opposite polarity, then it is known as a subtractive polarity. When this voltmeter it reads the sum of these two voltages, that is V1 plus V2, then the transformer is said to have what? The additive polarity. So this is about the procedure for polarity test of transformer. Now let us discuss steps to perform polarity test. What all steps is to be used in order to perform the polarity test on transformer. So again we can consider the same circuit. There is a transformer which consists of a primary winding and a secondary winding, and primary winding terminals are named as capital A1 and capital A2. Secondary winding terminals are named as small a1, small a2. The primary winding which is connected to a auto transformer in order to feed single phase supply. The primary winding which is connected across a voltmeter, that is V1. Secondary winding is connected voltmeter V2, and there is one more voltmeter V3 which is connected between the terminal of a primary winding and a terminal of the secondary winding. So what steps or what procedures are followed, so those are listed here. So here connect the circuit is as shown in the circuit diagram and set the auto transformer to 0 position. So initially we should ensure, so this auto transformer should be in 0 position. So then switch on the single phase supply. So once the single phase supply is switched on, so then just vary the auto transformer until it reaches the what? Rated voltage. So then record the values of voltages, that is V1, V2 and V3. If the reading of V3 it shows, so this is the V3, it shows the addition of the value of V1 and V2, that is this is what V1 plus V2. So then the transformer is said to be what? In additive polarity. If this reading that it shows what? The difference between V1 and V2, that is subtraction of readings V1 and V2, so then the transformer is said to be connected in subtractive or negative polarity. So this is the procedure is to be followed in order to perform polarity test on single phase transformer. So this is about the polarity test on transformer. What do you mean by the polarity test on transformer, and how the polarity test is to be performed on single phase transformer. So in next video we'll come up with another test on single phase transformer. Till then, take care.